welcome. I know it's first thing after lunch, but I guarantee you this talk is a lot less technical than the last one. For those of you who don't know me, I'm Winter-Paches. Daryl's my real name in real life. And I am, as I always in my shtick, I'm the oldest man on Urbit. I believe that's true. Maybe Jack, the EarthQL guy. He's the only one who could be. So I've been doing this for a really long time. And what I'd like to do is just expound a bit upon something that I think is still a problem for the industry as a whole, and also for Urbit. And as we are building a 100-year computer, we have to have a higher standard than the industry in general, not a lower one. So I'm going to talk a little bit about the history of testing. I'm old enough that when I first started coding, I didn't even have a monitor. When I first started coding, you sat at a thing that looked like a printer with a keyboard called a teletype. If you wonder where TTY comes from, it's a teletype. And you sort of typed blind, and then it would show you what you typed. And you used an editor called Ed. You can look it up, where you would say, oh shit, I typed a J in position 13. And that was how you typed a program in. You obviously didn't get much done, and you didn't think about testing at all, because it was just an accomplishment to get some tiny little program that did a mortgage amortization table working correctly. But then we got terminals. You could actually start doing some stuff that was a little more meaningful. And then we kind of went into the era where what everybody did was you had a big QA team, and you had all the structured process where the coders coded, and then you handed it over to QA, and they would put it through all the paces and all that kind of stuff. But the thing was that's not very scalable at all. You end up with 10 coders need 30 QA people just to keep up with them. You guys are familiar with that. So around in the mid to late 90s, and it initially came out of the Smalltalk community, became the idea that we should test using code. So and they called it unit testing. And the first unit testing framework was in 1998, and it was called SUnit. And I'm going to show it in a few moments. And then from that, all the other unit testing frameworks have basically branched out. Today, we theoretically should have, we've even put testing to the metal, right? Now you can test everything using code. You've got Selenium for UI testing, even in browsers and things. You've got continuous testing that's just constantly testing. You've got in your continuous integration, you're running testing. Ideally, we should be constantly testing the software to make sure that there's nothing wrong with it, right? I unfortunately think that there's sort of a meme over the time has crept in that, well, bugs are just what software has. You know what I mean? And releases always have problems, and oh my God, it's horrible, it's release day, right? But we really need to get out of that, because that's not true at all. And if you have good testing across all layers, you really should have very, very few legitimate bugs. And usually the only problems you have are what I would call more errors in understanding, right? That you didn't know what you were supposed to build. But it should always be exactly what you thought you were building. So I'm going to show you the first unit testing framework. Why are you not working? Whoop. Is that because I'm screen recording? It's not letting me switch applications. All right. Come on. Oh, here we go. All right. So this is a Smalltalk implementation called Squeak. It's one of the, it's very old. It's been around at least 30 years. And it's basically like almost how all Smalltalks work, in that this is your entire system. All classes, you can see here all the tests, right, for the entire system are all bundled up together. All the classes are in this is called the system browser, which you can browse every single class that you have available to you. So I just made a little demo example here of a two-class system that has Mr. Friendly and the jerk, and I've got two tests, and we'll see what happens. So basically, nope. This is what it was doing before. It's like dragging. Hang on. There we go. So I can run my tests. Go. Uh-oh. I have a failure. So now, being this is Smalltalk and everything's super dynamic, I can just click on the failure, and now it brings up my stack, my stack trace. But this is Smalltalk, so this is a live stack trace, right? So I can say, oh, looks like the problem is in test changing moods, right? So this is a little bit of interesting code, and I threw this in here because of a discussion I had with Neil Lagrev Nakvep to show you something super cool that you can do in Smalltalk, which is, so I start my test by instantiating a Mr. Friendly. I then become the jerk. So what I'm doing is I'm dynamically changing my class on the fly. And then I'm asserting when I call, hey there, it's Daryl, that he says, get away from me, Daryl. But clearly this test has failed. So I'm like, why did that test fail? So come on now. This trackpad doesn't like, okay, there we go. So now what I can do is I can just highlight a piece of code, because this is live, right? This is a live stack trace, live system. I can just say, print that. What's that? Oh, it's saying hello, Daryl. That doesn't make sense, right? It looks like I haven't become the jerk. So I can just delete that, and then I can go to my code, and I can look in the jerk, and I can say, now this is the method, right? Copy and paste error. I created this method, but just by copying and pasting it, I didn't correctly put in the right string, right? So I can just edit it, and I've got an extra space there. I can just save it. I can go back, and I can just say, proceed. Run selected, and I pass, right? And this was one of the coolest things about Smalltalk was you could literally, and this shows you kind of where test-driven development came out of, because the idea is I can just write tests and then code, and tests and code and tests and code, and never get out of the loop between tests and code, because they're joined to each other. So let's go back. All right. So why do we want to test using code and not having people do it? Well, the number one reason is it is extremely cruel to have humans doing over and over and over again things computers can do, right? I mean, our whole purpose is to automate things away from people doing it. So saying there's somebody else who it's their job to sit there and go click, click, clickety, click, and click around in my app and make sure that it works, That's not nice. Secondly, you can't progress unless you regress. There's nothing worse than software regression, right? And there's nothing worse that ruins the confidence of your user community than you do a release and something that used to work doesn't work, right? If it's a new feature, they'll usually give you the benefit of the doubt, right? Like, oh, something happened, you didn't do it quite right, right? But if this thing that's now not working, like, we know why they're connected, they're connected down under the guts, but they don't know why, and they start to think, oh, you don't know what you're doing, right? Like, why did this thing break? You didn't touch this thing, right? So and over time, that's how you lose your customers and your users, because they just think, this thing isn't worth it, right? So by taking a little bit of extra time up front to write the tests, you don't get regressions, right? Also, you don't want to write documentation. I've never met a developer who likes to write documentation. I hate it as well. But if you have a good unit test, comprehensive unit test suite, that is the documentation for your code, right? And that's how other developers can also know how to use your code, right? The problem with written documentation, as we've all seen, and just go to the Urbit docs on the website today, is it is almost impossible to keep them up to date, right? And similarly to the problem with regressions, every time even me as a developer go to the website and I look at the docs and the doc is wrong, right? That lowers the percentage chance that I'm going to go there next time, right? And after a few times, I'm like, I give up. These docs suck, right? But a good unit test suite has to be correct, because you don't ship unless it works, right? So it always gives other developers a place. When I look at new code, the first place I go to is the unit test suite to see, how does this thing work, right? And then finally, I've worked at places where they had ridiculous processes around trying to avoid things like merge conflicts, right? Because, oh my God, we don't want merge conflicts. They're such a pain. They get resolved wrong. You get bugs because people resolve them wrong. But I guarantee you, if you have a good unit test suite that covers most of your code, if not all of your code, you never have to worry about a bad merge conflict resolution again. A test will fail if you did it wrong, right? All right, and then reasons to test first. Okay, so hopefully I've convinced you should have unit tests. Now I'm going to try to convince you why you should write them before you write your code. Good code design always starts with thinking about the interface first, right? You have to think about, how is this going to be used by your customers? If you're writing a software library, your customers are other software developers, just the same, right? But if you're writing software that people are going to see, you have to think, what is the interface going to look like? How is it going to be used, right? And unit tests and other tests aid in thinking about, how do I call this thing, right? So the first unit test you should always write is just a call to your thing. It's going to fail because there's nothing there, right? But it gets you to think about the proper boundaries in the interface, right? And if you're having to construct all this shit before you call this thing, well, maybe you should think about simplifying your design. Take a step up, make another class or something, right? Like your design. I have never seen code that is hard to test that is good code. Or inversely, all good code is easy to test, right? Because it's specific, it doesn't do a lot of things, right? It's easily unit testable. You can't refactor unless you have unit tests, right? Because the very essence of refactoring is, I've coded this thing, all my tests pass, I'm on green, right? If you are refactoring properly, right, every change stays green, right? I mean, if it goes red, I mean, you can make a change, but the essence of refactoring is you're not breaking anything. You're just changing the implementation. None of the interface, none of the external things are changing when you're refactoring. If you're changing those kind of things, you're redesigning, you're not refactoring, right? And then the other thing is I have never seen it not true, because the point of this talk is lots of double negatives, that people who wait to test to the end, eventually they're like, there's not enough time to test, just ship it, right? It inevitably happens, so test first. So what are you gonna get? You're gonna get improved confidence in your code. You'll get faster feedback when there's problems with your code, and you will sleep better, right? I always tell the guys on our team, I want to be the world's most boring software development team. I don't ever want to get called in the middle of the night. I want to be able to release twice a week without ever worrying about it. I don't want to release patches. I just want to release, right? And that's in the, if you slow down a little bit and you write more tests up front, trust me, you will have a happier life. Okay, once you get good at unit testing, there's lots of cool stuff you can do with it that you might not think about at first. And these are all things that I've done at various times. You can have tests in your system that, so all of us have integrated with something where you were like, oh my God, what idiots, right? Like I can't believe their system works this way, right? Like I had to integrate with an API one time that returned errors with a 200, right? So you got a 200, but you got an error body. And not only that, it sent it back with invalid JSON, right? So I had to have code that not only, right, I couldn't rely on the return code. Oh, and I did point out I have an appropriate shirt on today. I had to make sure that, okay, they said 200, but is the body something that looks like JSON, right? I couldn't throw it right into a JSON parser because that would blow up because it wasn't valid JSON. So anyway, so when you've got things like that, what you can do is you can actually put a test in that will fail if they fix their API. And then oh, okay, I can take these hacks out of my code now because their API is actually returning the right error message. You can have what I'm calling canary tests, right? Like I've done a lot of integration, so you'll see a lot of this is around integrating with external systems, and it might be one of the reasons why I'm very big into testing. But what I would do would be I would write, the worst thing is in production in the middle of the day, oh, we didn't get the orders from so-and-so, or the inventory is wrong now, what the hell's going on? Oh, they changed their API and they didn't tell us, right? You can have tests that run validating that the API, and you generally don't want these as part of your test suite, right? Because you don't want external calls, especially in your unit test suite. But you can have them scheduled to just validate, okay, their API is still the same, right? Maybe they run once a day, maybe they run once an hour, right? Because trust me, people just change their APIs and they don't even tell you about it. You can make sure that your code is handling all logic cases. What we did when I was at a company called HedgeServe is, we did this because of when we were reading about the initial, that Netflix chaos monkey, right? And we strictly did TDD. We had basically 100% code coverage. So we wrote code that in our integration environment went into our code and swapped greater than signs to less than signs, right? And then ran our test suite. And then if the tests passed, that was a failure, right? Because that shouldn't, your test suite should fail if you change. And the other thing we did was we would delete lines out of our source code randomly and then run the test suite and see if it still passed, right? Which would mean that, you know, we had missed something because, or we had code that we didn't need, right? Because you could delete it and everything was fine. General tips and tricks for testing. Keep your tests small. Don't test a lot of things in each test, right? Because that makes it hard to figure out if they don't work, which one is falling. Make sure they're fast. Nothing makes people stop running tests as much as tests that are slow. What you can do is if you have slower tests, you know, segregate your test suite into faster tests and slower tests potentially. Keep your tests independent. Nothing. The nightmare when you're testing is, oh, these tests work except if this one runs before that one, right? Like you don't want that. A lot of good unit test suites actually randomize how the test methods are run to kind of smoke these things out anyway. But keep them independent. Use descriptive names because once again, you can, if you look at the names in our production test suite, it reads like a spec, right? You know, when I do this, I expect that. When I do that, I expect that. When I do this, I expect that, right? And always the test has to fail the first time. You have to see it fail. Especially once you start doing things like mocks and stuff, it is easier than you think to write a test that never fails. And then you're not testing what you think at all. All right, so now I'm gonna actually show, so I've been working a bit on unit testing based on some of the stuff LagRev has done. I've just got some general tips if you're testing Gall apps and general Hoon. Always use expect equal rather than just expect. It just gives you more information, right? Like even if you're just testing, you know, it gives you one step before. This is another thing that I've always, since doing Smalltalk, if you implement as tape on your cores, you always have sort of a printable, human-readable representation of what the hell's in there. It will help you figure out what's going wrong faster. And you can create, use a door, right? And you have your tests instead of just being a regular core. If you do a door, you can then use a fake bowl, right? And the fake bowl is really good for making your test deterministic, right? And you can use it to do a setup and a expects. And so I'll show kind of how that looks. Why is it doing this again? Come on. It's not letting me switch apps again. All right. This is, oh, there it is. I got it. I think I got it. What the? Oh, come on. Goodbye.
Are you using Eclipse?
No, VS Code.
Okay.
With VI key extensions.
Yeah, made for Eclipse.
Yeah. All right. So this is sort of the naive implementation of just a door with a fake bowl, right? But then in your tests, you know, you can populate your fake bowl simulating essentially what your app is doing, right? Because your app gets past that bowl, and if your creation uses things from the bowl, you have to be able to deterministically control what that is, right? But this gets annoying after a while, right? Because you got a lot of these things. So what you can do is, let's get the cursor up here. Where is the cursor now? Hello, cursor. Oh, maybe this will work. Somehow my keys have gotten. Here we go. So extending that idea, right? You can create multiple fake bowls, and then you can have a setup method, right? So that you can, so what I've done is, I've created a structure just to hold data, test data, right? And I am all ears if people know that this is a dumb way to do this, because I'm probably the dumbest Hoon programmer here. But this was all that I knew how to do it, is I have a structure that I can fill, and then with different of the fake bowls, and then I have expectations. And this just allows me to refactor my tests, so I don't have, the tests themselves aren't laden down with all kinds of repetitive. So then the tests kind of end up looking like this. And I'm gonna share this. I'm gonna put all this code out there in public so that you can see it. But then your tests look more kind of like this, right? And now they're units, because not all the tests use all the data, so they kind of have to be units. So these are techniques, I think, which make testing a bit more tractable, that you can do right now without even changing anything about the testing framework, and you can write lots and lots of unit tests in Hoon. You can, and this is from the article, Lagrève's article, which I have a reference to earlier, but this shows how to test the poke of an agent, right? And what you do is you build a sort of a fake state. You poke it and put data in it, and then you can test your basically your fake state that your code did the right thing and put it in state correctly, right? And then for testing your on peak, right? You kind of do the same thing. You fill your state, but then you just call on peak directly. I was helped with this. I think Mark was on that call on how to do this. But this is really the only, because you can't do it the way you do it in the dojo with the .cat or whatever. But you can test both pokes and peaks, so then you have no excuse for why your agent returns strange things. Let's see if I can possibly get back to the presentation. All right. So yeah, the article I was talking about was A Guide to Urbit Unit Testing by Neil Davis. And there's a link there. I'm going to publish a slideshow as well. Jack Fox wrote a good article on inductive testing, which is basically making sure you're testing edge cases and things, that has a lot of similar techniques. And these are just some other articles about testing. Let's see. If you do download the repo that goes with the Guide to Urbit Unit Testing, the repo that's on GitHub is broken, but I have already submitted a PR to it. They haven't merged it, It's been a couple of months, but just look for my PR, and then you'll have a working example. And I also wanted to highlight macrep great unit tests in re.hoon, which is a great library that you should be using. Regexes, I use it all the time. Excellent tests. The new test agent that they talked about earlier, this is really good and is probably a more advanced. My stuff is a little bit oldie moldy compared to that, but this is probably the way of the future is PalFun stuff. And then the app I was showing you there is called Rank. It's for making rank ordered lists and sharing them. I've been working on it for a while, it's not public yet, but I will publish it. Questions? Sarla.
You talked about writing tests first.
Yes.
How do you think about the interaction or like handoff between like UX and design of like this is what we want the application to do, and engineering who's then kind of taking that and going, okay, these are the tests for this, and then here's the code.
Well, ideally, you could write visual tests that described exactly what you were doing. Now, the problem there is and this is actually one of them. There's a platform, SaaS platform called Mabel, and this lets you visually write tests. It's expensive. The other way to do those kind of tests is using like Selenium frameworks. But the problem with Selenium frameworks are they're hard to keep in sync, right? They're very fragile, right? So you usually need a team just writing Selenium tests. So that's the visual aspect is the harder aspect of it. I would recommend though, the more you can put in the model and the controller, the better you are, because then there's less chance,
I'm thinking like less like UI, this button shows up this color with these rounded corners.
Okay.
More like, okay, user comes to the page, they can do these 6 things.
Right,
and
right.
if they do this thing, they can go this path. And
Yeah, I would encode those in more like of a feature test, right? Because all of your things should have an interface that they're calling, right? Like in the case of an agent, right? I'm gonna do the following pokes, right? So have tests that say when I do poke, 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 state should look like this, right?
Do you have thoughts on how you find the right scope or size of individual behaviors to test?
No, because my opinion now, and some people would disagree with me, I admit, I'm a little bit of a zealot on this, but I literally start with almost nothing, right? Like my first test would be, that it has this variable, essentially, right? And of course it doesn't, because I potentially haven't even written it yet, right? It has nothing. And it fails, and then I add the variable, right? And then I go from there, right? And then I build up, because those kind of tests are super fast anyway, right? And you do, just like regular code, you can refactor tests, right? So you can put tests in, and then after a while you're like, oh my God, every test is testing the same thing, right? Like I have now 5 tests that hit this variable. We'll take the old ones out. That's fine, right? And now this is an area where I don't know of it, but I don't think Urbit has good support of this. But if you're in any other language, right, you run things like code coverage to see, what paths am I covering and which ones am I not. And that reminds me of one thing which I didn't mention is, particularly in this phase in Urbit, I would consider you don't have to test Urbit using Hoon, right? Like, you could easily spin up in one of the many languages that let you spin up, say, a Selenium web browser-based testing framework simply, right? You know, PHP, Laravel, Rails, Python, Django. You know, you could spin up a side project that tests the Urbit code from the outside, right? Because once again, you're writing you're thinking interfaces, right? You're thinking, how do I interact with this system, right? So the interactions can come from any language, and I've done that many times in the past, where particularly in the dim past, when my systems were in C, and you know, writing unit tests in C is not fun, right? It has no dynamism at all. But like particularly once .NET came out, I would write unit tests in C# that tested C, right? Because you know, so there's nothing that says your tests have to be in the same language as the code.
I think there's something there where, yeah, like in some sense you're always going to be testing your code from the outside, but then which outside you use, or like what you expose, or how you factor your code even, might affect what you're able to test trivially. Because if all my agent's logic goes inside the agent, I always have to go through a Gall interface. But if it makes use of a bunch of libraries, I can test those libraries by hand, right?
But that's part of what the testing helps you see, right? Like like say I'm testing my Gall agent, and I'm like, oh, this is such a pain in the ass. I have to set up this huge, complicated bowl, or what, you know, just to figure out if it works right. The thought process is exactly that. Like, you know what? If I extracted this out as a much smaller lib, I could test each piece. I still know that it works, right? And then all I have to do is one test on the outside that makes sure that they all hang together correctly, right? All right. Thanks, everyone.